Welcome to our journey through the solar system, our corner of the cosmos, a cosmic ballet of planets, moons, asteroids and comets, all dancing around a star we call the Sun. Today we'll explore each planet one by one, uncovering their unique properties, gravity, dimensions, orbits around the Sun and rotations around their axes. From the scorched surface of Mercury to the icy plains of Neptune, we'll uncover the wonders of these celestial wanderers and gain a deeper appreciation for our place in the vast cosmic tapestry. Our first stop takes us to Mercury, the smallest planet in our solar system and the closest to the Sun. Imagine a world where the Sun blazes in the sky, dwarfing its appearance as we see it from Earth. This proximity results in extreme temperatures, with scorching days reaching over 800 degrees Fahrenheit, and frigid nights plummeting to minus 290 degrees Fahrenheit. This stark temperature difference is due to Mercury's lack of a substantial atmosphere to trap heat. Mercury races around the Sun in a swift 88 Earth days, making it the fastest planet in our solar system. But while it speeds around the Sun, Mercury rotates on its axis incredibly slowly. One rotation takes 59 Earth days, which means a single day on Mercury lasts for almost two-thirds of its year. Imagine the sunrise, a slow, drawn-out affair on a planet where days are longer than years. This unique characteristic adds to the intrigue of this small, enigmatic world. Our next destination is Venus, often called Earth's twin due to its similar size and composition. But don't let that fool you. Venus harbors a hellish environment that's anything but Earth-like. Shrouded in a thick atmosphere of carbon dioxide, Venus experiences a runaway greenhouse effect, trapping heat and raising surface temperatures to a scorching 900 degrees Fahrenheit. This heat is intense enough to melt lead and makes Venus the hottest planet in our solar system, even hotter than Mercury, despite being farther from the Sun. Imagine a landscape perpetually blanketed in thick yellowish clouds of sulfuric acid reflecting sunlight and giving Venus its high albedo. These clouds also obscure our view of the surface, making it difficult to study. And as if the intense heat and toxic atmosphere weren't enough, Venus also rotates on its axis in the opposite direction to most planets, a phenomenon known as retrograde rotation. This means the Sun on Venus rises in the west and sets in the east, adding another layer of peculiarity to this enigmatic world. As we leave the scorching heat of Venus behind, we arrive at our own home Earth, a vibrant oasis in the vastness of space. From a distance, Earth stands out as a pale blue dot, a color reflecting the vast oceans that cover over 70% of its surface. Our planet is unique in its ability to support life, a characteristic owed to a delicate balance of factors. Earth's atmosphere, composed primarily of nitrogen and oxygen, provides the air we breathe and protects us from harmful solar radiation. The presence of liquid water, a rarity in our solar system, is essential for all known life forms. And our planet's distance from the Sun places us in the habitable zone, a Goldilocks region where temperatures are just right for liquid water to exist. Earth spins on its axis once every 24 hours, giving us our day-night cycle. This rotation, combined with the tilt of Earth's axis, creates the seasons, driving the cyclical changes in weather patterns across the globe. As we continue our journey, we carry with us the understanding that Earth is a precious and fragile world, a reminder to cherish and protect our pale blue dot. Our journey continues to Mars, the Red Planet, a celestial neighbor that has captivated our imagination for centuries. This rusty hue, visible even to the naked eye, comes from iron oxide or rust prevalent on its surface. Mars is a planet of stark contrast, with towering volcanoes, deep canyons, and polar ice caps. Its thin atmosphere, composed primarily of carbon dioxide, is too thin to support liquid water on the surface for extended periods. However, evidence suggests that liquid water may have flowed on Mars in the distant past. We see signs of ancient riverbeds, vast outflow channels carved by catastrophic floods, and minerals that form in the presence of water. This tantalizing evidence suggests that Mars may have once been a warmer, wetter, and potentially habitable planet. Today, robotic rovers roam the Martian surface, exploring its geology, searching for signs of past or present life, and paving the way for future human exploration. Our journey takes us now to Jupiter, the largest planet in our solar system, a gas giant so massive that it dwarfs all other planets combined. If Earth were the size of a nickel, Jupiter would be about the size of a basketball. Jupiter is a swirling mass of colorful clouds driven by powerful winds that whip around the planet at hundreds of miles per hour. These clouds, composed of ammonia ice, water vapor, and other trace elements, create stunning bands and storms, including the Great Red Spot, a massive storm system that has raged for centuries. Jupiter's immense gravity affects the entire solar system, influencing the orbits of comets and asteroids. Deep within Jupiter's atmosphere, the pressure and temperature increase dramatically, eventually transitioning into a strange state of metallic hydrogen. This bizarre form of hydrogen, found only in the cores of gas giants, conducts electricity like a metal and is thought to be responsible for Jupiter's powerful magnetic field. Next, we encounter Saturn, a planet instantly recognizable by its stunning ring system. These rings, composed of countless particles of ice and rock, range in size from tiny grains to enormous boulders. They stretch out over 175,000 miles from the planet, yet are remarkably thin, averaging only about 30 feet thick. Imagine gazing up at this celestial marvel, the rings casting ethereal shadows across Saturn's cloud tops. Saturn is the least dense planet in our solar system, so light it could float on water if we had an ocean big enough to hold it. Like Jupiter, Saturn is a gas giant, composed primarily of hydrogen and helium. It's home to a diverse collection of moons, each with its unique characteristics. From Titan, with its thick atmosphere and methane lakes, to Enceladus, with its icy geysers erupting from its south polar region, Saturn's moons hold clues to the formation and evolution of planetary systems. Our journey now takes us to the outer reaches of our solar system, to the ice giant Uranus, a planet shrouded in mystery. Uranus is tilted on its side, with its axis of rotation nearly parallel to its orbital plane. This unique tilt gives Uranus extreme seasons, with each pole experiencing 42 years of continuous sunlight followed by 42 years of darkness. Imagine a world where a day at the pole lasts for over 4 decades. Unlike the gas giants Jupiter and Saturn, Uranus and Neptune are classified as ice giants. Their composition consists of water, ammonia, and methane ices, which form a slushy mantle around a small rocky core. Uranus has a faint ring system, much fainter than Saturn's, but still a fascinating feature. These rings are composed of dark, icy particles, thought to be remnants of a shattered moon or comet. Our final stop takes us to Neptune, the 8th and farthest planet from the Sun. Neptune is a world of deep blue, a color that comes from the presence of methane in its atmosphere. This gas absorbs red light from the Sun, giving Neptune its distinctive hue. Neptune is a planet of extremes, home to the fastest winds in the solar system, reaching speeds of over 1,200 miles per hour. Imagine winds so powerful they could sweep you off your feet. These winds whip around Neptune, creating massive storms and cloud formations. One such storm, the Great Dark Spot, was observed by Voyager 2 in 1989 but has since disappeared, showcasing the dynamic nature of Neptune's atmosphere. Neptune's discovery is a triumph of scientific prediction. Astronomers noticed irregularities in the orbit of Uranus, suggesting the gravitational pull of an unseen planet. Through careful calculations and observations, Neptune was discovered in 1846, adding another chapter to our understanding of the solar system. Thank you for joining us on this cosmic journey through our solar system. We've visited scorching hot planets, frigid ice giants, and everything in between. We've marveled at the diversity and wonder of these celestial objects, each with its unique story to tell. Our exploration of the universe continues, and there's always more to discover. From the mysteries of black holes to the search for life beyond Earth, the cosmos beckons us to explore its infinite possibilities. Thank you for visiting Physics Around Us. Please like, share, and subscribe for more fascinating explorations of our universe. Until next time, keep looking up and asking questions about the universe around us.